You typed your Gmail password into a third-party app last week, and the app stored it, in plain text. OAuth 2.0 exists, so you stop doing that. Before OAuth, every app that wanted your data asked for your username and password. Print app wants your photos. Hand over your Google login. Calendar app wants your meetings. Same thing. One leak, and every account that shares that password is wide open. You can't revoke access without changing the password everywhere. There is no scope. There is no consent. There is no log. OAuth 2.0 is an authorization framework, not authentication. Authorization. A valet key. It starts the car. It doesn't open the trunk. The third-party app gets a token with limited power for a limited time that you can revoke at any moment. The spec is RFC 6749, October 2012, almost 14 years old. It powers your login with Google, login with GitHub, login with Apple, every single one. If you've ever clicked one of those buttons, and you have, you've used OAuth. But here's the part nobody told you. OAuth doesn't replace your password. It still gets used. Once. The whole protocol exists to make sure your password never touches the third-party app. Ever. Every OAuth flow has 4 roles. If you can name all 4, you understand OAuth better than half the developers shipping it. Here they are. Role 1. Resource owner. That's you. The human who owns the data, your photos, your email, your contacts. You decide what gets shared. Role 2. Client. The third-party app asking for access. Slack wants your Google Calendar. Slack is the client. Role 3. Authorization server. The gatekeeper. Google, GitHub, Auth, Okta. They handle login, consent, and token issuance. Not your data. The keys to your data. Role 4. Resource server. The API holding the actual data, often the same company as the auth server, often a totally different team inside that company. They check the token, they return the data. There are several OAuth flows. The one you should use, for 99% of apps, is authorization code. 7 steps. We're walking through everyone. Pause if you need to. Step 1. You, the resource owner, click Login with Google on a third-party app. That's it. That's the trigger. Nothing else has happened yet. No password, no tokens, just a click. Step 2. The client app redirects your browser to Google's authorization URL. It attaches 4 query parameters: client ID, who is asking; redirect URI, where to send you back; scope, what permissions; response type equals code, what kind of grant. Step 3. Google's authorization server takes over. It authenticates you. Your password goes here and only here. Then it shows the consent screen. This app wants to read your email. Allow? You decide. This is the moment most developers misuse OAuth. They request every scope under the sun. Read email, send email, manage contacts, full drive. You should ask for the minimum. Always. Step 4. You hit Allow. The authorization server redirects your browser back to the client app, to that redirect URI from Step 2, with a short-lived authorization code in the URL. Not a token. A code. Step 5. The client's backend takes that authorization code plus its client secret and posts them to the token endpoint. Server to server, no browser. The auth server checks the secret, checks the code, and returns the actual access token. Step 6. The client calls the resource server's API. It puts the access token in the authorization header. The literal string is bearer space, then the token. Bearer means whoever bears it, uses it, so don't leak it. Step 7. The resource server validates the token. Is it signed? Is it expired? Does it have the right scope? If yes, it returns the data. If no, 401. That's the loop. Click, redirect, login, consent, code, exchange, token, API. That's the entire dance. Every login button on the internet is doing exactly this every time you click it. Now ask yourself, what's actually inside that token? Because there isn't one token, there are 3, and mixing them up is how people get hacked. Access token. Short-lived. Usually 1 hour, carries the scopes. This is what travels on every API call. If it leaks, the attacker has at most 1 hour. That's the design. Refresh token. Long-lived. Days, weeks, sometimes forever. It can mint new access tokens without asking the user again. Never put it in the browser, never log it. Treat it like a password, because it functionally is one. ID token. Optional. Only shows up when you're using OpenID Connect, the identity layer built on top of OAuth. It's a signed JWT containing who the user is, name, email, subject ID. You verify it, you don't send it to APIs. Access for calls, refresh for renewal, ID for identity, mix them up, and you ship a security bug. Quick question. Why does the auth server send a code first, then make the client trade it for a token? Why not just send the token directly? Because the URL is public. Browser history, server logs, refer headers. Anything in a URL can leak. But here's the kicker. On a mobile or single-page app, the code itself can get intercepted. A malicious app registers the same redirect scheme and grabs it. So in 2015, IETF shipped PKCE, Proof Key for Code Exchange, RFC 7636. Before redirecting, the client generates a random secret, the code verifier. It hashes it with SHA 256. That's the code challenge. It sends only the challenge with the auth request. Later, when it exchanges the code, it sends the original verifier. The auth server hashes it and compares. If they match, real client. If not, rejected. And here's where it gets serious. OAuth 2.1, currently at Draft 15, makes PKCE mandatory for every client, public, confidential, mobile, web, all of them. The optional era is over. May 3, 2017, around 1 million Gmail users got an email, Open in Docs button. They clicked. They saw a real Google consent screen from a real Google domain. They clicked Allow. The trick, the malicious app was literally named Google Docs. It wasn't, but OAuth doesn't verify display names. They asked for read, send, and manage your email, plus manage your contacts. Whoever clicked, Allow handed over their inbox. The script then emailed everyone in their contacts. A worm. Google killed the campaign in about an hour. Restricted apps named after Google products. Tightened verification. But the lesson is permanent. OAuth's security depends on you reading the consent screen. The protocol can't read it for you. Read the scopes, every time. If a Tetris clone wants send email on your behalf, close the tab. That's not paranoia. That's hygiene. 3 things change in OAuth 2.1. If you're shipping auth code today, write these down. 1. The implicit grant, response type equals token, sent straight back in the URL fragment, is removed. It always leaked tokens through browser history. It's gone. Use code with PKCE instead. 2. The resource owner password credentials grant, where the user types their password directly into the third-party app, is also removed. The original sin. Finally fixed. 3. PKCE is required for every client, public or confidential, server or browser. No more recommended for public clients. Mandatory. 5 rules. HTTPS only. Never plain HTTP. Least privilege. Request the smallest scope that ships. Short access tokens, 15 minutes to 1 hour. Rotate refresh tokens on every use. Validate signatures, expiry, and audience server side every single call. Memorize these. Ship them. Now I want a number. Drop in the comments. What's the worst OAuth scope you've ever been asked to grant? The wildest, this Tetris clone wants full drive access moment. I'll pin the best one. Subscribe to Code Brainery. Next video, we're tearing apart JWTs.